U.S. Air Force just shocked the world with a mind-blowing announcement: the unveiling of the highly anticipated SR-72 DARKSTAR aircraft in Jerusalem. This advanced aircraft is set to redefine aerial capabilities with its advanced technology and remarkable speed. Being the successor of the fastest and most lethal aircraft ever created, the DARKSTAR promises even more sophisticated features than its predecessor. What were the mind-blowing features of the SR-71? Is the SR-2 considered more technologically advanced than its predecessor? Join us as we unveil the features of the recently revealed SR-72 hypersonic aircraft that is ready to take the world by storm. Although long retired, the United States Air Force's SR-71 Blackbird still holds several records as the fastest plane to ever fly. Well, it did, until the capabilities of its successor, the SR-72, was unveiled to the world. Regardless of the fact that it's already retired, the Blackbird left its impact in the world of military aviation. It was a high-speed, high-altitude spy plane that could fly at over Mach 3. Built by the American aerospace company Lockheed Corporation, it was developed in the 1960s as part of a secret project from the Lockheed A-12 by the Skunk Works division, led by engineer Clarence Kelly Johnson. Its design, which was inspired by the A-12, aimed to be less detectable by radar. Originally considered for a bomber role, it was eventually focused on reconnaissance. The SR-71, which was larger and could carry more fuel in a two-seat cockpit compared to the A-12, was unveiled to the public in July 1964 and began service with the United States Air Force in January 1966. It was retired in 1989 for political reasons, briefly brought back in the 1990s, and finally retired again in 1989. NASA used it for research until 1999. For its reconnaissance missions, the SR-71 was equipped with advanced sensors, radar, and cameras. It operated at speeds of Mach 3.2 and altitudes of 85,000 feet, allowing it to outrun or avoid threats. If a missile was launched at it, the Blackbird would simply speed up to evade it. Since its retirement, its role has been taken over by reconnaissance satellites and unmanned aerial vehicles. A new UAV, the SR-72, is being developed by Lockheed Martin and is expected to fly in 2025. As of 2024, it still holds the record, set in 1976, for being the fastest air-breathing manned aircraft, a title previously held by the similar Lockheed YF-12. Before we check out the mind-blowing capabilities of the successor of the fastest aircraft in the world, let's refresh our memories on what the Blackbird was like and the exact capabilities it offered the USAF. Before the SR-71, Lockheed built the U-2 reconnaissance aircraft for the CIA, which was relatively slow. In late 1957, the CIA asked Lockheed to create an undetectable spy plane. This new project, named Archangel, was led by Kelly Johnson, head of Lockheed's Skunk Works in Burbank, California. Work on Archangel began in mid-1958, aiming to create a plane that could fly higher and faster than the U-2. Over 10 months, 11 different designs were drafted, with the A-10 design leading the pack. However, its shape made it easy to detect by radar. After a meeting with the CIA in March 1959, the design was changed to reduce its radar cross-section by 90%. On February 11, 1960, the CIA approved a $96 million contract for Skunk Works to build 12 spy planes named A-12. The need for faster reconnaissance planes became clear when Francis Gary Powers' U-2 was shot down in 1960. The SR-71's journey from concept to legend is a fascinating tale of innovation and secrecy. The designation SR-71 continues the legacy of the pre-1962 bomber series, with its predecessor being the XB-70 Valkyrie. Interestingly, a bomber variant of the Blackbird initially received the designation B-71, which stuck even after the change to SR-71. During the final testing phases of the B-70, there was a proposal to adapt it for a reconnaissance strike role, earning the designation RS-70. However, the A-12's superior performance led the USAF to order a variant of the A-12 in December 1962, which Lockheed initially named R-12. This new version was longer and heavier than the A-12, featuring a longer fuselage for extra fuel, a larger two-seat cockpit, and reshaped fuselage Chinese. It was equipped with advanced signals intelligence sensors, side-looking airborne radar, and a photo camera. The CIA's A-12, flying higher and faster with only one pilot, boasted a superior camera and more instruments. While the A-12 conducted covert missions, the SR-71 took on overt operations with USAF markings and pilots carrying Geneva Convention's identification cards. The story took an interesting turn during the 1964 presidential campaign when Republican nominee Barry Goldwater criticized President Lyndon B. Johnson for lagging behind the Soviet Union in weapons development. To counter this, Johnson revealed the existence of the YF-12A USAF interceptor, which also served as a cover for the secretive A-12 and the USAF reconnaissance model. USAF Chief of Staff General Curtis LeMay preferred the SR or Strategic Reconnaissance designation and successfully lobbied to change Johnson's speech to refer to the aircraft as SR-71 instead of RS-71. This led to a mix-up in the media, with the press receiving transcripts still using RS-71, creating the legend that the president had misspoken. To keep the A-12 under wraps, Johnson only mentioned the A-11 while hinting at a high-speed, high-altitude reconnaissance aircraft. In 1968, Secretary of Defense Robert McNamara canceled the F-12 interceptor program and ordered the destruction of the specialized tooling used for both the YF-12 and the SR-71. Despite this, the legacy of the SR-71 lived on with the production of 32 aircraft, 29 SR-71As, 2 SR-71Bs, and 1 SR-71C. The SR-71 remains a symbol of cutting-edge aerospace engineering and a testament to the daring ingenuity of its creators. The SR-71 was built for incredible speed, flying at over Mach 3, with a two-man crew in tandem cockpits. The pilot in the front cockpit flew the plane, while the reconnaissance systems officer in the rear operated the surveillance systems and navigated the mission flight path. This aircraft was an early example of stealth design made to minimize its radar cross-section. The SR-71 was painted a dark blue, almost black color to help release internal heat and blend in with the night sky, earning it the nickname Blackbird. Its main defense wasn't just radar countermeasures, but its ability to fly at high altitudes and very high speeds. These traits made it nearly untouchable at the time. When enemy radar sites tried to lock onto the SR-71 and fire a missile, the plane would often be out of range before the missile could even reach it. If a missile did get launched, the SR-71 could usually outrun it by simply accelerating. Small changes in speed, altitude, and direction were often enough to break any radar lock. The SR-71 could fly at sustained speeds of more than Mach 3.2, faster than the Soviet Union's fastest interceptor, the MiG-25, which couldn't reach the SR-71's altitude. Throughout its service life, no SR-71 was ever shot down, highlighting its remarkable design and capabilities. On most aircraft, titanium was too costly to use extensively, typically reserved for parts exposed to the highest temperatures, like exhaust fairings and wing edges. However, the SR-71 used titanium for 85% of its structure, with the rest made from polymer composite materials. To keep costs down, Lockheed chose a titanium alloy that was easier to work with, but softened at lower temperatures. This led to new fabrication methods, later used in other aircraft manufacturing. For instance, they discovered that welded titanium had to be washed with distilled water, as tap water's chlorine causes corrosion, and cadmium-plated tools also couldn't be used for the same reason. Initially, 80% of the titanium they received had to be rejected due to contamination. The SR-71's high-speed flights generated extreme temperatures, requiring unique design solutions. Major parts of the inboard wings were corrugated instead of smooth, allowing them to expand without splitting or curling. A concept similar to the 1920s Ford Trimotor's corrugated aluminum skin. The fuselage panels were designed to fit loosely on the ground, aligning correctly only after thermal expansion in flight. This caused the aircraft to leak fuel on the ground, which was a hassle for ground crews. The cockpit's outer windscreen was made of quartz and ultrasonically fused to the titanium frame, reaching temperatures of 600 Fahrenheit during missions. Cooling was managed by cycling fuel behind the titanium surfaces. On landing, the canopy temperature was over 572 Fahrenheit. Some SR-71s had red lines on the wings to mark no-step areas, indicating fragile spots supported only by widely spaced ribs. The Blackbird's tires, made by B.F. Goodrich, contained aluminum and was inflated with nitrogen, costing $2,300 each and needing replacement after about 20 missions. The SR-71 landed at speeds over 170 knot and used a drag parachute to reduce landing roll and minimize brake and tire wear. Titanium was hard to find in the US, so the Skunk Works team had to get creative. They ended up sourcing much of it from the Soviet Union. Colonel Rich Graham, an SR-71 pilot, explained how it happened. The SR-71 is made of 92% titanium. At the time, the US didn't have enough of the ore needed, called rutile ore. It's found in only a few places around the world, with the USSR being a major supplier. By working through third world countries and fake companies, the team managed to get the ore shipped to the US to build the SR-71. Engineers added Chinese, sharp edges extending from the nose along the fuselage and canted the vertical control surfaces inward. Special radar-absorbing materials were used in sawtooth-shaped sections of the skin, and cesium-based fuel additives helped reduce the visibility of exhaust plumes, though the plumes were still quite noticeable. Despite these efforts, Soviet radar technology eventually caught up. The Chinese were not in the early A3 design, but a doctor at a CIA front organization discovered that a shape with flattened, tapering sides reflected most radar energy away. This insight led to the adoption of Chinese for the A4 through A6 designs. The Chinese generated powerful vortices, creating additional lift and improving aerodynamic performance. This allowed for a reduced angle of incidence on the delta wings, enhancing stability and reducing drag at high speeds, which meant the aircraft could carry more fuel and other payloads. Landing speeds were also lower, as the Chinese vortices created turbulent flow over the wings, making it harder to stall. The chines functioned similarly to leading-edge extensions, increasing agility like in fighters such as the F-5, F-16, and MiG-29. This design change also allowed the removal of planned canard foreplanes. While the Blackbird is well known among aviation experts and military enthusiasts, less is known about its potential successor, the SR-72, son of Blackbird. Expected to take flight in 2025, the SR-72 is being developed by Lockheed Martin as a follow-up to the legendary Blackbird. This new aircraft is designed for surveillance, intelligence, and reconnaissance. The big question is, will it live up to the hype? The first whispers about the SR-72 surfaced in 2007, with claims that Lockheed Martin was crafting a plane capable of flying at Mach 6, which is over 4,000 miles per hour. In 2013, Aviation Week in Space Technology officially revealed Lockheed's work on the SR-72, drawing so much public interest that it overwhelmed their servers. The Lockheed Martin SR-72 is a hypersonic unmanned aerial vehicle concept that is designed for intelligence, surveillance, and reconnaissance. Introduced in 2013 by Lockheed Martin as the successor to the retired SR-71 Blackbird, it aims to push the boundaries of speed and stealth. In 2018, Lockheed Martin executives announced that a test vehicle could be flying by 2025, with the aircraft entering service in the 2030. Aviation enthusiasts have been buzzing with speculation about this new aircraft, especially since the SR-71 famously evaded more than 4,000 missiles during its time in the air. The successor aims to be even faster, designed to reach hypersonic speeds over Mach 5.0, outpacing modern air defenses. Brad Leland, Lockheed's program manager, explained the significance of this speed. He revealed that hypersonic aircraft, coupled with hypersonic missiles, could penetrate denied airspace and strike at nearly any location across a continent in less than an hour. This technology is set to be a game-changer in military strategy, much like stealth technology has been. The development of the SR-72 involves cutting-edge advancements. The original Blackbird was powered by the unique Pratt & Whitney J58 turbojet engine, often called a turbomjet. It will need an even more powerful engine to meet its high-speed goals. The quest for hypersonic capabilities is heating up, especially as tensions rise between major world powers. The USAF and PLAAF are developing their next-generation fighter and bomber programs, while Moscow is also working on hypersonic technology. To achieve these blazing speeds, Lockheed Martin teamed up with Aerojet Rocketdyne in 2006 to develop a suitable engine, evolving from the scramjet-powered HTV-3X project. The SR-72 aims to use an air-breathing, hypersonic propulsion system, allowing it to accelerate from a standstill to Mach 6 with the same engine, doubling the speed of the SR-71. This requires a complex engine design capable of handling subsonic to hypersonic speeds. Traditional turbojets work best up to Mach 2.2, ramjets excel around Mach 3, but can reach Mach 6, while scramjets handle high supersonic to hypersonic speeds. The SR-72's engine would combine turbine and scramjet technologies, using a shared inlet and nozzle but separate airflow paths. Flying at such high speeds creates extreme heat, necessitating the use of advanced composite materials like carbon, ceramic, and metal mixes, which were previously used in missiles in the space shuttle. By 2017, the SR-72 was envisioned as both an intelligence and strike platform, though existing payloads were likely insufficient for its high-speed, high-altitude capabilities. New sensors and weapons would need to be developed. Plans for a scaled demonstrator, roughly the size of an F-22 Raptor, began in 2018, with flight tests expected to follow. The SR-72, about 100 feet long, was projected to enter service by 2030, aligning with the Air Force's goal of developing hypersonic strike and reconnaissance capabilities. Despite the Air Force's interest in hypersonic technology, funding was not secured for the SR-72, partly due to budget constraints. Instead, the Air Force opted to develop the Northrop Grumman RQ-180 stealth UAV for reconnaissance missions, considering it cheaper and faster to produce. In December 2014, NASA gave Lockheed Martin a contract to explore building the SR-72 engine using current turbine technology. The approximately $800,000 contract was for a study to see if a TBCC propulsion system, which combines a turbine engine with a low-speed dual-mode ramjet, was feasible. Previously, Lockheed found that speeds up to Mach 7 could be reached with an engine that combined turbine and ramjet tech. The main challenge with hypersonic engines is bridging the gap between a turbojet's top speed of Mach 2.2 and a scramjet's starting speed of Mach 4. The study considered modifying existing jet engines to handle this gap. If successful, NASA would fund a test vehicle for the DMRJ. Aerojet Rocketdyne also got a contract from NASA to help with this. In March 2016, Lockheed Martin's CEO said they were close to a breakthrough that would let their SR-72 hypersonic plane hit Mach 6. She suggested that building a demonstrator the size of an F-22 could cost less than $1 billion. By June 2017, Lockheed Martin planned to develop the SR-72 by the early 2020s, aiming for speeds over Mach 6. They said the technology was ready and they were working with DARPA to make it happen. In January 2018, Lockheed's VP highlighted how 3D printing and computer modeling advancements made the SR-72 possible. In February 2018, another Lockheed executive clarified that while no SR-72 had been built yet, hypersonic research was progressing towards reusable vehicles. By November 2018, Lockheed stated that an SR-72 prototype was expected to fly by 2025, equipped with hypersonic missiles, and it would enter service in the 2030s. Complementing the lethal capabilities of this newly developed hypersonic aircraft is the LAWS. The Laser Weapon System, or LAWS, is a laser beam, a precise instrument of destruction that annihilates targets with a shocking precision. The LAWS system is not just a weapon, it is a proof of the effect of evolution on military arsenals. Traditional defense mechanisms are rendered obsolete when faced with the speed and precision of light-based weaponry. The system works by generating a high-energy laser beam that is focused and directed onto targets with extreme precision. The laser's energy is then absorbed by the target, causing damage or destruction. They can be used to neutralize incoming threats, such as missiles or enemy aircraft, by effectively melting or disabling their components. The SR-72 appears to have no equal regarding aerial combat, or does it? Experts believe the only aircraft capable of rivaling this technological marvel is another sixth-generation fighter developed in the United States under the Next Generation Air Dominance, or NGAD program, a program initiated in 2014 and has an estimated investment of $16 billion and is being operated by the United States Air Force. Boasting speeds of over 1,800 miles per hour and a flight ceiling of 15 miles, it possesses a stealth coating for evading radar detection and features a sophisticated laser weapon countermeasure system. However, its true standout feature lies in its artificial intelligence, which allows the fighter to control a swarm of drones. The first type is reconnaissance drones, equipped with highly precise radars that can track any movement within a radius of 46 square miles. With the NGAD and the hypersonic SR-72, the future of the USAF has never looked so promising. Thanks for watching. While you are still here, click on the link on your screen to check out another of our videos. See you there.